Welcome to Azure Virtual Training Day, DevOps with GitHub. My name is Pimparkar, and I'm a Microsoft technical trainer based out in Sydney, Australia. Now, the whole session is going to be in two parts. Part 1 has 3 modules. Module 1, we talk about the basics. What is DevOps? What is DevSecOps? Source control, Git, GitHub, and how do we integrate it with Teams and VS Code. Module 2, we talk about workflow of DevOps. Example, agile branching, infrastructure as a code. Module 3, we look at it from a security perspective. Example, GitHub security features, how to secure containers and Kubernetes. Part 2 is in 2 modules, Module 4 and Module 5. Module 4, we talk about CI/CD, continuous integration and continuous development. Example, pipeline, GitHub actions. And Module 5, we'll talk about monitoring and maintenance. Now, please note that this lecture corresponds to AZ400, the Microsoft certificate for DevOps professionals. And you can find the corresponding courseware at aka.ms/AZ400. Now, let's go ahead and let's get started. Now, again, the agenda for the whole session is we start with Module 1, getting started with DevOps. Then we'll talk about managing the flow of work. Then we'll go and talk about shifting security left in our CI/CD process. Then delivering changes to cloud. And lastly, we'll talk about the importance of performance monitoring and maintenance. Now, let's consider this scenario where you're working for a company called Tailwind Traders. Now, they're growing rapidly. And as a result, senior members are seeing different goals across teams, which is causing challenges in collaboration and communication. Their response, they heard about this new fancy thing called DevOps that will help them to better their communication and sharing. And they want to implement DevOps. But now, what is DevOps? Now, DevOps, in a layman term or in a simple way, is developer plus operations. Now, let's talk about DevSecOps. Now, DevSecOps, as the word says, it's developer, security, and operations all together. So on face value, both words mean to join some of the common roles we see in development workflow into one role. Now, before we talk about sec part in the DevSecOps, we must first talk about DevOps. Now, typically, the DevOps team combines development and operations. The same team can be responsible for full cycle of development. That's plan, develop, operate, and deliver, all in one team. Now, this then helps the team to share a common goal. And as Donovan Brown, our fellow colleague at Microsoft, puts it, it's a union of people, process, and products to enable delivery of value. Now, technology, like platform as a service, which enables self-service, its quick, scalable deployments, plays a key role in enabling DevOps. Now, in DevSecOps, we incorporate security team into our DevOps practices. Now, security is the responsibility of everyone on the team. Securing application is a continuous process embodied in the design phase, the coding phase, the operations, and monitoring, from start to the end of development. Organizations that adopt DevSecOps can expect to get great benefits. They can shift their security left to occur at more critical points through the development lifecycle and get a low vulnerability remediation time. We'll explain a lot about shifting security left in detail in Module 3. It forms a seamless workflow by integrating it into existing tool chains. It also continues to identify new threat vectors. Now, this slide may seem a little bit complicated, but we won't go into too much detail because Module 1 is only about getting started on DevSecOps. But basically, the idea in DevSecOps is continuous security validation should be added at each step of the development workflow. This approach aims to start the conversation about security from early on, like in design and validation, and also at a later stage like monitoring and auditing. The diagram highlights the critical validation points where we'll do this check. Now, what does this all mean? At essence, DevOps or DevSecOps concerns the delivery of value. Now, value here means value delivered through software or apps as user experience. Example, an internal app that supports customer service will increase customer satisfaction because it delivers value to them. But how? Now, DevOps is closely tied to something called as agile, and we'll talk more about it in Module 2. Increasing efficiency, eliminating waste, feedback loop, continuously improve, and deliver fast. Now, these all go back to the idea of agile. For now, simply say that it's a mindset represented by optimizing what you have to deliver and what your users actually need. Now, traditionally, in development, often there's a wall of confusion between dev and ops and also the security team because they do not know what each other is working on. They do not know what issues each other are facing. You can change the process from top down. You can change the technology relatively easy, but people are the hardest to change. In order to shift to DevOps culture, we need a cultural shift. Now, a typical process in DevOps starts with planning, then development, then we go to deliver and go into production. And then we operate the software. Unlike in traditional development, which stops there at a perfect product, in DevOps, we go into a new cycle and start with planning all over again. The first tool we introduce in your DevOps toolbox is GitHub and Git, a popular source control tool amongst DevOps. Now, what is source control? It is a form of version control. The version here means the code's version. Source control is not an invention in DevOps. The source means the source code, so it literally means to manage or control the source code and its version or history. It uses the concept of centralized code repository stored on a local PC or on a web server. It changes to code will be tracked within the repository. It will also allow collaboration by enabling different contributors to add their own changes in parallel, compare them, merge these changes, roll back, and track issues. Most common tools used are Git and Subversion. We'll mainly talk about Git as it's more favored in DevOps. Now, GitHub basically means Git hosted on github.com. Now, Git is representative distributed source control tool, and some others include Mercurial and Baza. Now, what is distributed source control and what is it good for? Now, distributed source control has a few strengths. It has cross-platform support. That means teammates using Mac, Linux, or Windows can contribute to one code base without any hassle. It's open source. That means its friendly code review model helps the owner to easily review, compare the proposed changes, select which to merge, or even which to roll back to an older version, while minimizing confusion and conflicts. It has offline support. Every developer can clone or download a copy of the whole repository to their local computer to work on it. It's got portable history. Now, once a developer clones the repository, everyone's work history will be included in it. It has an enthusiastic user base. Now, Git is a famous distributed source control, and many corporate and private projects use Git. Because of its growing user base, you have a growing community support, which basically means more resources, more mature practices, and more security. It is best used for smaller size open source projects, which are distributed unsupported by cross-platform teams. Now, GitHub is the leader in Git repository hosting. Do not mistake Git for GitHub. Git is the technology that allows you to create a repository and maintain the history and everything. GitHub is Git hosted publicly on GitHub domain. Git itself is open source, and you can host it anywhere. Example, on your local computer, in your closed on-prem environment as well. But many still choose to put their code on GitHub, which is Git hosted on the community hub. Why? Because GitHub has better expertise sharing, which is enabled by a big community of developers. It has cross-team collaboration. It is easy to reuse code by others, and others can use yours. It has support for cloud-based development environment in features called as code spaces. It has support for easy deployment to other platforms through features like GitHub Actions. And we are living in an open world. And we at Microsoft are putting many project source code on GitHub as public. Now, if public visibility is a problem, you have an option of private repo on GitHub Enterprise, which can be used to create repos unseen to the public. When we say increase velocity, we mean velocity as in the speed of development. Now, GitHub is the largest open source community. GitHub allows you to automate from code to cloud, secure software together, do seamless code review, have code and documentation in one place. You can coordinate, manage your team together on GitHub. Now, GitHub plays an important role in DevOps culture. GitHub encourages the culture of sharing, collaborating, and the sense of all developers as a big community. As a result, many open source tools, packages, and libraries on GitHub are now standard equipment which are shared in the developer community. The community use and feedback, that means the tools that need to evolve and keep up with the newest trends and needs are done with the same standard of security. Now, when Microsoft acquired GitHub in 2018, it announced that it will remain as an independent open source platform. And it was a big statement and a love letter towards the sense of community. Now, let's look at some basic components of Git project. The code base is stored in something called as a repository or a repo. Think of the assets in the repo, kind of like a bunch of files stored in a folder-like structure, which will then contain the code, the documentation, configuration files, and so on. The Git also remembers the history and version. Now, often, repos will include a .gitignore file, which allows you to tell Git to ignore files that you do not want Git to keep track of. When anyone downloads the repo, they get a full history and other team members' work progress. Different working progress of the code can be isolated and stored together in something called as branches. Example, you may have one brain branch to store the stable code version, while having a development branch where you add new features. Then we have commits that are used to record certain updates. Example, you can commit after you edit your configuration file, and the README file to get them ready to be uploaded into your repository in cloud. Now, tags are often used to mark a specific version. Example, you can tag the most recent commit in branch production as release 3.0. Now, on the right-hand side of the slide, you can see a typical Git project structure. At top level, we have a readme.md file, a file that works as a documentation explaining how to install and set everything up. Then we have security.md, a documentation for your security policy. A license file that explains the license when using this project. Example, can anyone use it for free, or do they need something to credit you? Code owners file that defines people responsible for the code. And then we have pull requests from other developers to reflect the proposed changes. Then issues, a place for others to report issues, bugs, or request features. And then releases, a page that contains bundles of the versions of the releases. Now let's take a look into GitHub's features. Security, where we review code and identify vulnerabilities early in the development cycle. Repos or repository, which is a core feature. It hosts the code base, history, and branches on cloud on github.com or on-prem if you wish to use something called GitHub Enterprise. There are a few more features. Actions, where we create automation workflow with environment variables and customized scripts. Packages, where we ease integration with the numerous existing packages and open source repositories. Code spaces provide cloud-hosted collaborative development environment. Copilot uses an OpenAI codex to suggest code and functions in real time from editor. Now, as mentioned before, Git can be hosted anywhere. We have more choices for source control other than GitHub. Now, GitHub is Git hosted on github.com. Azure DevOps is Git hosted on Azure. Now, both can work well with Azure Automation, which provides support for automating your workflow on Azure, like deploying to a virtual machine. Both have easier collaboration and can roll back to your earlier version of your runbook, which is like a written guide for how to run your automation with Azure Automation. You have a push code feature where you can push code from Azure Automation to source control, or the other way around. In fact, Azure DevOps existed before GitHub was acquired by Microsoft. If you're not using Azure Automation, with most PaaS services on Azure, you can choose whichever product your team is more comfortable with. After all, both GitHub and Azure DevOps can be used to push code to Azure really easily. GitHub is newer, so you can expect to see more features coming. Now, when we collaborate on GitHub repo, we use something called as PR or pull request. Now, the pull request or PR is a very important term and expected to come up again and again throughout a session. When someone wants to reflect their changes to the code base, they will create a PR, which is basically a request to pull the changes from their own working branch into a more stable branch, which is called the main. When a PR is created, the team leader or repo owner will do a code review to see if there are any conflicts or issues. Example, conflict between two versions of code or any bugs, and discuss them before they approve the PR. When all issues are resolved, we can merge the changes with a click of a button. Now, imagine if everyone on the team, all of them start working concurrently and making a PR towards the same branch. It can be chaotic. Often we avoid this by coming up with branching strategy. A classic strategy is defined in the GitHub flow. You can read more about it in the GitHub documentation. Basically, you start from a default branch, often called the main or the master, and always go back to it. For example, I want to implement a feature that adds user pick. I create a user pick branch based on the main to work on. This is sometimes called a feature branch because you create the branch only to add a new feature. I make the necessary changes. Example, add a picture element in the user profile page, add a logic to the user controller. I make a pull request from user pick to the main. Now the whole team will review this PR together. Ideally, if no one added any new changes to the user profile page and the user controller in main, there should not be any conflict. Then if the team approve it, we can merge the PR and then delete the branch. History is stored in the repo, so no need to save the working branch. Now let's take a look at it on the actual UI. Now we are going to take a look at GitHub in action. So as you can see, Tailwind Traders has uploaded their website into github.com. This project is called Tailwind Traders-website. This is the main branch. Within the main branch lives the code for our main branch. As you can see, there are a number of other different branches that we could work on. Our repository also contains important files like our license. Right here, you can see that MIT open source license file for this project. Also, we've got the README file, which is a markdown that's rendered below. It shows information about repository or project and things like requirement, prerequisite ways to deploy the project. This is a very important step in creating your project on GitHub. There are also other tabs at the top like pull request. This shows us all the open pull requests, which are requests to merge changes from one branch to another branch. This is where our team will collaborate and communicate and review changes together before they ever happen to our main code base. There's also a tab for GitHub Actions. This is where you would go to set up or manage your workflow through GitHub Actions for CI/CD, that's continuous integration and continuous delivery, like we spoke about earlier. There's a security tab that shows you things like security policy and security advisory. If you don't have a security policy, you can set it up here as well by clicking the Setup Security Policy button. Click Start Setup. This will pre-populate with a sample security policy. You can see the markdown, and now you can see that this security policy is showing supported and unsupported version, and it's also showing us how to report a vulnerability. You also have access to Insights tab that shows you different analytics about your project information and things like your community traffic, how many commits you've had, how many pull requests you've had, and other information of that nature. There's also a setting tab, and the setting tab gives you the ability to set up different options and manage access. And if you go ahead and click Manage Access, you can click Invite a Collaborator, and you can add someone to the team. So I'll add Jessica Dean. I'll invite her as a collaborator. I'll add to this repository. And now I'll just await her response so she can be part in making modifications to this repo. You can also use the security and analysis area to take a look at dependency graph and any vulnerability alerts. You can also go over here to branches and you can modify what your default branch is. Here we've got main, or you can go ahead and create branch protection rules that let you define things like disable force pushing or disable branches from being deleted. You can also set up moderation to enact temporary limits to restrict which users can interact with your repository for a 24-hour period. You can also set up webhooks that allow certain external services to be notified when certain events happen. And you can see that I've got one notification set up here within our team. Maybe you can have an email list or a user that wants to be notified via email. You can also set up in the notification tab. As you can see right here, I could have had an email address and set up notifications for a specific user. You can also set up integration to different services, create deploy keys, work with actions, or you can even set up secrets for your application while you do your deploy. Now let's go back over to pull request section, and we'll work on the pull request that I opened up when I made modifications to our security policy. So what we can do is go and take a look at the actual finds changed if we wanted. We could make comments right here in line and then eventually we can leave a review of any change. Now, typically someone else would be doing this, another member of our team. But today I'm just working on a demo. We'll go ahead and write a comment. We'll go back to the actual pull request. And what I could do now, if I wanted to, is I could go ahead and merge this request. Typically, that would be after an approval from another team member. So I can click pull request, merge, confirm the merge. It will send notification to my email address, and then my merge becomes closed. And I can delete the branch created. So there are a couple different ways that we could add a new file or make modifications to this repository. And so what I'm going to do is, first is I'm going to show you how to go ahead and clone it. So you can go to code, go to clone, and copy this. Go over to my terminal and then type git clone. So now we have Tailwind Traders website repository on our local computer. We can go into this and see the files. Our git clone is a git command line utility which is used to target an existing repo and create a clone or a copy of the target repo. So I want to create a new file into this repository. And what I'm going to do is go ahead and click create new file. I can type the name. So I'll just call it collab.md. I'll just add a quick comment. Now I'll create a new branch to start a pull request. So you'll see right here, here's my main branch. I'll propose the new file. It will go through a create pull process. And then you can see here, because of the branch protection, I've got a review required. And merging is blocked in order to get this new file into my repository's main branch. And now we can go back to our pull request. We can go to create collab. And we see that now there's a whole section that requires us to go ahead and add an approval. So I'll go ahead and merge this pull request. I'll use my administrator privilege and confirm that merge. And now we'll delete that branch. Now I'll do a get pull command, which is used to fetch and download the content from the remote repo. And now you can see that any changes that were made in the portal have been gone ahead and pulled down into my local repository on my computer. If I'd like to create a branch from my local repository, all I've got to do is type git checkout -b and then the name of my branch. So I'll call it B123. And now I've got a new branch. And I can go ahead and git push by setting upstream of this new branch. So if we go back to GitHub portal, we can now see that B123 has now been added as a branch. Now next up, we'll look at a few features and tools that will extend our understanding of GitHub beyond the basic features. Now Microsoft Teams is the hub for teamwork. In terms of core feature, it is a messaging tool. But with Teams, you can also chat, meet, call, and collaborate with your teammates from anywhere. And get what goes perfectly with GitHub, Teams. Now we have a native integration between Teams and something called as GitHub Enterprise. Now GitHub Enterprise basically is a plan that allows corporate users to create their unique environment, which is safe and unseen to the public. If you have GitHub Enterprise, you can integrate Teams with it using something called as connector. Your team will be able to see the notification from GitHub directly on Teams channel, which will send updates and changes on the GitHub project. Your team can also watch and interact with things like commits and pull requests, because what the connector sends into the channel is completely customizable. Now, time for a quick demo. Now that we know what Teams is, let's show how it can help enable collaboration at Tailwind Traders. So as you can see, Tailwind Traders has set up Microsoft Teams for collaboration. And you can see in here, I've already got some notifications because I've made some changes to our team. So you can use an experience in a standalone app as well. You can also use an experience in browser from office.com. Both are basically the exact same service. So within here, our general channel, you can see that I have my files that I may want to access in OneNote. You can see right here, if I click directly, it will bring up the OneNote I might have. So if I want to leave a note, we also have a section which has our Tailwind Traders docs. So this is a Word doc built right into it. This is where we keep our OneNote meeting notes. So I've got this document right here. We can also take a look at our SharePoint. Our SharePoint is directly connected. You can see I've got one of our files here. for DevOps team policies. We can go and take a look if we'd like. I've also set up some different channels for different purposes within my team. So let's take a look at Azure DevOps board channel. So you can see right here now, I've got GitHub updates channels right here on the left, and you can see we have connectors. And inside this connector is the setup for GitHub Enterprise Connector. And so you can see I've got to go to Configure, Manage, and so all my GitHub updates that will be done will come in as webhook. So what you'll do is you'll follow the instructions to create the webhook. You'll basically enter this into the GitHub website and select the kind of events you want to push into the notification area. So go ahead and click Cancel. This channel, as you can see, contains notification about changes to stories of different work items and how we actually are currently doing with our Tailwind Traders DevOps board. And if I want to, I can go up here. I've got a tab set up right here in Teams. I don't have to leave the experience. I can see my work items. And just to show you, looks like this particular one is done. It means that Jessica has finished giving me a review. So let's go ahead and click on that. As a user, I want to be able to modify my particulars, pushing the PR today. So let's take a look at PR. And what we can do right here is see that there's one new comment on a commit. So let's view in GitHub. And you can see that Jessica has gone ahead and provided me with a review on this particular change. So I can go ahead and just say, thank you. Leave a comment on this comment. And if we head back to Teams, we'll see here that my new comment has been left. And it's in the channel. And we can also take a look here at the top at the pull requests we currently have, because I've created a tab for you. So you can see right here, I've got a few files. Let's go ahead and go to this update collab one. Looks like I have a review required. And all of this is done within the Teams experience. So I don't have to actually leave and go into a browser. So I can make any changes if I'd like. I go in and see the file that was actually committed and any changes that may have been done. The GitHub Enterprise integration is just one of many. If you go ahead and click down here, this is more added apps. And you'll see various applications that we can utilize in order to extend the possibilities of Teams. So one of the strengths of Teams is that not just only for chat and notifications, it's also for making calls. My calendar is also available here in Teams, so I can review any meetings I may have. Teams really looks like it's going to help our team collaborate better. And let's see what's next. Now let's talk about Codespaces. Now, Codespaces are cloud-based development environment that can be hosted on GitHub. Normally, before you start developing on a new PC, you need to spend some time setting up a local environment. Example, download VS Code, install it, download GitHub for Windows, then install it, download the code to your local computer, install the required runtime, packages, developer tools, and so on. Codespaces allow you to skip all of that. It's basically cloud-based, so computing resources are allocated by GitHub. It has features like syntax, highlighting, auto-completion, debugging, and Git interface. What you need to develop on local is all included. Now, GitHub Codespaces allow you to develop online. You can avoid any issues with old hardware or software. They're browser-based, so you can work on any OS, any device, anywhere with internet using a familiar UI based on VS Code. We'll talk more about VS Code in the following slides. It's portable as it's browser-based. It will protect you against proliferation of intellectual property. You can work from PCs, tablets, and Chromebook. They're easy to connect to Codespaces from VS Code, and they're great for demo collaborating and to quickly start a light-weighted project. Now let's take a look at the actual Codespaces in a UI environment. So one of the great ways to be able to work together and share is by utilizing the Codespace feature. So we can use cloud editing, where we can actually share a repository without doing any local cloning. So we can go ahead and actually take a look here. There's all these different types of machines that we can utilize to create a code space. So this will be the workspace that we use to edit, build, and eventually deploy from. So we can go here and you can see it's setting up a code space. It creates our image, creates our container, and then eventually connects us up. Now you can see that we've got a fully functional version of Visual Studio Code within here. And you can see it's asking me if I want to set up extensions. What we can do is authorize our account and click continue. And now what we can do is use this. So we've already done that. We'll just close that. And you can see we've also got a terminal that we can work with. So I could use some help figuring out why this has failed. So what I'm going to do is I'm going to call up one of my colleagues, Jessica, and see how we can use this together. I could use a little help, so I'm going to get in touch with Jessica Dean, who is going to help me figure out why this won't deploy properly. Now let's give Jess a call.
Hey Jay, what's up?
Hey Jessica, I'm running into a problem. I want to show you real quick. I've been working with this company called Tailwind Traders. And if you take a look right here, you can see that I've got this part within build and publish with .NET in my workflow file. For some reason or another, and I'm getting this build fail. So I was curious if we could use a live share session and see if we can troubleshoot it together. And so we're going to go in, and you can see right now that Jessica has joined a collaborative session. I was kind of looking at here at prod.yaml, and I've got my section right here. And I see a highlight here. That I'm setting up a .NET core. So I was so curious if you may know something about why this error is happening.
Yeah, so let's take a look at a few steps here. You're deploying your web app, you check out your code, and the next step is you're just going into building. And then I can even see you're installing dependencies in the Tailwind Traders source folder. Let me go take a look at your Docker file here. So I'm going to drop down into Tailwind Traders website source, Tailwind Traders web again, and here's the Docker file. So if you take a look at lines 1 and 2 right there, unless you override those arguments, this Docker file is expecting .NET 5.0. That's the issue, is you just have to specify the .NET version in your workflow YAML file.
Awesome. Thank you so much, Jess. I'll send you the PR in just a few minutes. So thanks to Jess, I was able to figure out why this workflow run was breaking. And if we go over to code, we go here and into a workflow. It's right here in this Azure prod YAML file. So I'll go into branches, and I'll just create a patch O2. I'll create this branch, and within this branch, I'll go ahead and I'll modify this to 5x. All right. We can just go here, and so I'll just go ahead and I'll change it to 5, and then I'll start my commit. Updated.net. And then what I'm going to do is commit directly to this branch. And once I've done that, I go back to the front. I can create a pull request, and we're going to do it off my repository. And we'll just create that PR. And so I need a review. I'm going to send this over to Jess. And I've got my approval from Jess. So it looks good to me. So what I can do now is merge my pull request. It will merge the pull request, and I can just click this right here and delete this branch. And after I've deleted the branch, I can go here over to actions, and I can see it's kicked off a new build. Now I'll take a look at the build. So that's going to run, and I'll see how my build goes as soon as it's finished. So our GitHub action build is now completed. You can see the green. No problems here, the buildings that was published with .NET. So let's go ahead and take a look at it. Now all I've got to do next is go to my Azure and click on the URL. And hey, my website looks like it's working. Now time for another tool, Microsoft DevBox. Now the purpose of Microsoft DevBox is close to code spaces. They provide a ready-to-code, flexible, secure environment for a hybrid team, where some might be in office, but some might be connected to the workplace remotely. Like code spaces, DevBox allow you to create a self-service, ready-to-code environment with hibernation and easy restart. You can work with any tool and any workload, and it can be accessed on any OS or browser. It works with the latest Windows, and it is also secured and centrally managed. You can also own your workstation because you have a dedicated computing resource to match your project demands. It has support for any IDE or SDK tool that runs on Windows. It has support for desktop, mobile, web, and more. It has features like WSL and nested virtualization support, which helps you with your day-to-day development. It has separate dev boxes for different projects, proof of concept, while maintaining legacy applications. In fact, MS DevBox is a complementary service to Codespaces. Codespaces is a feature of GitHub. DevBox is a Microsoft service. Codespaces are hosted on github.com, while DevBox are hosted on Azure. Codespaces only work with native cloud applications, example web apps for APIs, which has no OS dependencies. DevBox works with desktop programs, IoT, or mobile apps too. So if you intend to work on these instead of web app, Microsoft DevBox can be a better choice. Now, another DevOps favorite tool is a Visual Studio Code, which is often called as VS Code. Now, what is Visual Studio Code? Now, VS Code is a lightweight and a powerful source code editor. It has many must-have features that DevOps love. It works on any OS, Mac, Windows, or Linux. It is built-in command line tool, and you can integrate any console tool into it. It has many extensions to be added freely. We also have features like syntax highlighting and easy debug mode, which can be integrated with other plugins. It is open source itself and completely free. Personally, I've seen many devs switch over from other editors to VS Code in the last 5 years or so. Now, one thing that makes VS Code really powerful is the variety of extensions. It has over 30,000 extensions from Microsoft and other third parties. It covers language support, tooling support such as developer tools, connectivity support, deployment support, and multi-cloud support. You can get all of them on Marketplace anytime. And you can use them to standardize practices and make work easier in your team. Now let's take a look at a popular extension, LiveShare. It allows one developer to share their work with other devs live. For example, you can share the same terminal, you can remotely suggest edit to the code, and other devs working on the same repo can see your edits real time. Same for debug. You can make audio calls to other devs or chat with them as well. So do remote coding review together. And it's really easy to set up without any online meeting. Now let's go ahead and give it a try. Now in this demo, we'll look at how we can tie it all together using Visual Studio Code. So let's do a quick overview of Visual Studio Code. I've got up here my Tailwind Traders website repository. And I actually cloned this from GitHub. And what I can do is go to File, and you can see we've got all these different things here that we can access. We can go to New Window, and then we have the ability here to go to Explorer, open folder that we may have locally, or clone a repository. And as you can see here, an upgrade for an extension just popped up. Now, extensions are a huge part of VS Code. And what we can do here is take a look right here on the side and see that we have all these different extensions installed. And probably the most important ones that we have access to are the Azure ones. And so we have all these different Azure services that we can log into, connect up onto our Azure account. So let's go back actually to now looking at our repository. And now you can see on the left, I've got many files in different directories. On my right, I actually have the code that I'm working on. And in this case, it's a YAML file. And what's really great about the extension, and the reason why I mentioned, is there's also language extensions. I've installed the YAML extension, which gives me additional YAML linting and support. What we can do is see that this particular file is YAML. So if I go here into deploy web app prod, I can add an extra line, and I just have it broken. You can see that we've already got something that shows that YAML is not going to work. What we've got is some broken YAML. So I can just delete it. And it's been corrected. Another great feature in Visual Studio Code is its integrated terminal. So you can utilize this terminal to do regular commands that you may do on any other terminal. Say in your Mac, or in your Windows, or even in Linux. And so one of the great things I can do here is I can run git status and see that my branch is behind locally by one commit. So I can just type git pull and pull my changes locally. And now I have the most recent version of the main branch here on my local computer. So why don't we start completely from scratch and create a new file? So what I'm going to do here is just go to save as, and I'm going to call it aks0102.bicep. And that's going to create a bicep file, which is a template using domain-specific language for ARM. ARM stands for Azure Resource Manager. And just like we mentioned, there's a bunch of code snippet that comes along. So let's say I want to do a resource. You can see that there are different recommendations of different resources we can create. And in this case, I want to create an AKS cluster. So we can see here, resource AKS cluster. And within here, I have a complete snippet of all the things that we can utilize to create a new bicep cluster. We can add things like parameters, and it has here the defaults. It allows me to go ahead and give it a name, give it a time. And you can see that there's an auto completion. And so there's no use of this default value anywhere in here. So if I go ahead here and change this to name, it will go ahead and start utilizing this parameter as the name here. So you can edit your files obviously right here in Visual Studio Code if you need to. And if you can see on the left side, we've got our application public. We've got our different files in here. If I go back to package.json, you'll see that it recognizes this as a JSON file. And here are all versions of different NPM modules that we have installed. Now, if I want to make a change somewhere in this app, so let's just go here to this twd demo file. And I want to say, let's create a new branch to create this in. So we'll create a new branch from, and what we'll do is we'll give this a name. We'll call this patch02. So then we'll state where we actually want to use as our source. And we'll use the main branch. And so now we can go ahead and say hello, 123, part of our change, and save it. And now we can go to source control here on the left, and we'll see we've got a pending change. And so what I can do is I can commit this change and go ahead and add this tab to my GitHub. So I'm going to hit plus, which is going to stage the change. And then all I have to do is provide a commit message. So this is a message on why exactly we are adding patch02. So patch02 fixes demo. And then what we'll do is we'll hit enter, and then we can push clone and all the other things we need to do. I'm going to sync, and sync will make sure that we have our patch02 uploaded. And then we can say where we want to use, and we can see the fork of another branch. So I'm going to use my local one origin. And so now it's going to ask me if I want to create a pull request in GitHub. I can click create pull request. And you can see on here on the left, it's going to show the changes that I want to make them and where I want to make them. So I'm going to say I want to make it to jdestro tailwind traders -website repository. And I want to do my change against main. So now I can just go ahead and say new pull request and click create. And now you can see right here, integrated into our VS Code, is the change that I want to make. I can add reviewers. So I can add Jessica Dean here. Okay. I can add labels, I can add milestones, and I can actually look at the change. So you can see here, I went over to the actual GitHub website, and you can see right here that we've got a patch pull request. I'll take a look at it now. Now you can see that's actually running a build and deploy. So it's kicked off a GitHub action to go ahead and test everything. If I have any specific tests that are going to run, it's going to do my unit test. It's going to make sure that everything can be merged. So what we're going to do is take a look at what exactly is going on with this build. With GitHub Actions, you can accelerate your continuous integration and continuous delivery process by utilizing workflows right within the GitHub website. What you can do is utilize this service to go ahead and work with your build. So you can see it's based on workflows, and these workflows essentially help you to do things like setting up your job, setting up version of your node that you may need, and we'll then eventually install any kind of dependencies that are required. We'll build and publish our change to .NET. We'll log in via Azure CLI. So this will take a few minutes. So let's let this build and we'll go back to it. So let's take a look at GitHub workflow really quick while this is building. If you can see, we've got this .github directory within the main root of our repository. And in here are workflows. And you can see here, that's Azure staging.yaml file. This is the workflow. And you can see right here, I've got it set as staging build. And so anytime a branch with this type, with the patch in its subject, we'll go ahead and we'll kick off a build. You can see all those actions that I've mentioned before. Specifies the version of the node, goes ahead and sets up all the other things that we need. And eventually will allow us to merge this in and have it to go into a production branch. And you can see our build is now complete. So let's take a look at our build process now. We are ready to go ahead and merge in our changes into the main branch. So let's go ahead and go back to pull request. We can do that here, or we can do this in the Visual Studio Code. Click merge, my pull request, create merge commit, and then once our merge commit is done, it will go ahead and it will add this change into a branch. So our pull request is successfully merged. So we don't need this branch anymore. So what we're going to do is delete both the remote and local version of patch02, and we'll hit OK. So when we merge into our main branch, we kicked off this Azure prod workflow. And you can see it says right here on push to branches main. So this will kick off an action within GitHub, and we'll go ahead and we'll bring that up. And we can see that it's broke. Oh boy. Well, if we're going to do it, we might as well see what's broken and see how we can fix it. So let's go in here and we'll go to build and deploy. And what we can see that someone here or somewhere here are building the publish with .NET that has failed. And we've got a build fail. That's tough. Well, we can go ahead and troubleshoot this. And there's a few ways we can do this. Now, one of the great things about GitHub is the ability to collaborate and work together to find answers. Now, time for a quick recap. Now, we know that Tailwind traders want to solve the problem of rapid growth, lack of collaboration, lack of shared tools. And as a start, we can help them with source control via GitHub, Microsoft Teams, Visual Studio Code for shared tooling, and a solid foundation for DevOps strategy. Now with this, we come to the end of Module 1. Thank you. Now we'll go for a short break, and I'll see you on the other side of the break.